Wagwan, my G's in 11R3. This is question 18. We're asked to work out the perimeter of this star. We're told that one of these little sides here is X. So really, if I want to work out the perimeter, if I can work out X there, and then I've got 18 of these X's around the outside, I can times that, whatever my answer is for X, by 18, and that will give me the perimeter of the star. What we're going to use here is the cosine rule, because I've got two sides and the angle enclosed by these two sides, so that means we're going to use the cosine rule. This angle here we can find by, if we draw dotted lines, so we're making these into equal triangles, and then this line here really is splitting this triangle in half. So if I sort of split these in half as well, what you'll find is you've got, I think it's 20 equal angles in, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 equal angles around that point there. And you should know that angles around a point add up to 360 degrees. So if we wanted to work out theta, we just do 360 divided by 18, and that gives me an angle of 20 degrees. So theta is 20 degrees. Then the cosine rule is given at the front is a squared equals b squared plus c squared minus 2bc cos a, where your a is the side that you're trying to find out, which in this case is x, so it would be x squared equals, b and c are the two sides that you're given, which enclose the angle. It doesn't matter which one you call b and c really. So we've got 10 squared plus 7 squared minus, and that's going to be 2 times b, which is 10, times c, which is 7, times the cos of the angle between them, which is theta, which we've just worked out to be 20. And then we just got to plug all that into my calculator. Make sure your calculator is in degrees. So we've got 10 squared plus 7 squared minus 2 times 10 times 7 times the cos of 20. And that gives me an answer of 17.443. And then to work out x, we just need to find the square root of that, which gives me an answer of 4.176, blah, blah, blah. So that's the length of one side, but we've got 18 of those, if you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So to get the perimeter of the star, it's just going to be 18 times 4.176. And if we do that, that gives me an answer of 75.2 centimeters for the perimeter of the star. Okay, for section B, they're asking us to calculate the perimeter of the star. Sorry, calculate the area of the star. Well, if we work out the area of this one triangle here, then again I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 of those triangles. So if I work out the area of one, I can just times my answer by 18, and that'll give me the area of the whole star. So there's another formula at the front of your booklet, on your formula sheet, which gives me the area of a triangle as a half AB sine C. So A and B are just the lengths of the sides enclosing the angle. So A would be 10, B is going to be 7, and then we're timesing by the sine of the angle between the two sides, which is theta, which we worked out in part A to be 20. So then you just plug all that into your calculator again. Half 0.5 times 10 times 7 times sine of 20, which gives me 11.97 centimeters squared to 2 decimal places. So that's the area of one triangle, but the star has 18 of those triangles, so we've just got to do 18 lots of 11.97. So we times our answer by 18, and that will give me the area of the whole star, which is 215.5 centimeters squared, and that is 15.